Hi, Assalamualaikum. My name is SITI QISTINA, and today our group will be presenting about Chapter 6, Gravimetric Analysis, with a specific focus on its application in the mining and metal industry. Before we start, these are all of our group members, and each one of us will be covering a different section of this chapter. So do follow along as we take you through the topic. Now, let us start with the basic. What is gravimetric analysis? Gravimetric analysis is a quantitative technique that determines the amount of an analyte in a sample purely through measuring mass. The analyte is chemically converted into a solid product, which is then separate, dry, and precisely weighed using an ultra-sensitive analytical balance. What makes this method stand out is that it relies on nothing but mass, no light, no electrical signal, giving us highly accurate and reliable results. How do we calculate the result? There are two approaches. First, the gravimetric factors, defined as an algebraic expression that converts gram of precipitate into gram of an analyte. It is the ratio of the formula weight of the substance solved to the substance weight. The formula is GF equal to FWA per FWP times A per P, where FWA is formula weight of the analyte, FWP is the formula weight of precipitate, A is mole of an analyte, and P is the mole of precipitate. Second, the chemical factors, defined as the calculations of the weight of a constituent in a sample directly from its proportion to the total sample weight. The formula is A% equal to A per W times 100%, where X is the analyte weight and W is the sample weight. The key equations is weight of an analyte equal to GF times weight of weighing form. Both methods ensure precise measurement, critical in the mining industry where metal content accuracy directly impacts production. That's all from me. I will pass this to the next presenter.
Hi, I am AMALINA, and now I will talk about types of gravimetric analysis. There are four main types of gravimetric analysis. The first is the precipitation method, where a metal ion is converted into an insoluble precipitate that can be filtered, dried, and weighed. The second is electrogravimetry, which uses an electric current to deposit a metal directly onto an electrode so its mass can be measured. The third is the validatation method, where a component of the sample is converted into gas and removed, and the change in the mass tells us how much of the component was present. And finally, thermogravimetry, which tracks how a sample mass changes as it's heated. Out of these four, the precipitation method is the most widely used, especially in industrial settings. And that's what we will focus on the rest of this presentation. So, why does the precipitation method stand out? First, it converts metal ion into insoluble precipitates, meaning the metal we want to measure separates cleanly out of solution as a solid. Second, that solid is easy to filter, dry, and weigh, which makes the whole process straightforward to carry out even at a large scale. And third, it offers high accuracy since the final measurement depends mainly on the precision of the balance rather than complex calibrations. Because of this combination of simplicity and reliability, the precipitation method is the most widely used gravimetric technique in industry today, which is why it's the main focus of our discussion.
Hello everyone, my name is PUTERI, SHAMIMI, EMELI, BINTI, ROSLI, and today I will explain the step involved in gravimetric analysis, which is a systematic process used to determine the amount of analyte based on mass. The first step involved is preliminary treatment. In this step, the sample is dissolved and prepared to remove any interfering substances that may affect the accuracy of the analysis. The second step is precipitation. In this step, a suitable reagent is added to the solution to convert the analyte into an insoluble precipitate. This allows the analyte to be separated from the solution. The third step involved is gradation, which is one of the most important steps in gravimetric analysis. This precipitate is heated and allowed to stand in the solution. This process forms a larger and pure crystals, which improve the accuracy of the final result. Next, filtration and washing. The precipitate is separated from the solution using filtration and then washed to remove any remaining impurities. Proper washing is essential to avoid poor precipitation, which can lead to error. After that, the precipitate undergoes drying and ignition. This step removes moisture and convert the precipitate into a stable form suitable for weighing. The sixth step is weighing, where the mass of final precipitate is measured accurately using any analytical balance. Finally, calculation is carried out, where the mass obtained is used to calculate the amount of analyte present in the original sample. In conclusion, each step in gravimetric analysis plays an important role in ensuring accurate and reliable.
For method application, the slide have 3 points. First, quality control of product. Gravimetric analysis is used to determine the composition and purity of metal such as iron, aluminium, nickel, and copper during manufacturing process. This ensures the final product meet industrial quality standard. Second, we have metal purity. Metal industry use gravimetric analysis to measure impurities and determine the purity of the refined metals. For example, purity of aluminium before it is fabricated into products such as aircraft component, automotive parts, construction materials, and beverage cans. Aluminium ions are precipitated as aluminium hydroxide and then ignite aluminium oxide. Lastly, monitoring metal recovery during refining. Gravimetric analysis help determine how much metal is recovered during refining processes. Industry use this information to improve production efficiency and reduce metal losses. Next, we go to mining application. For mining application, it have 4 points. First, economic value assessment. Gravimetric analysis is used in geological assay to determine the absolute purity and commercial grade of raw metal ores before high-cost mining operation begin. Second, it have quantifying base metal. The method measures major inorganic elemental cations such as cobalt, nickel, copper, zinc, and tin. For third one, we have assaying method for precious metals. Assay are the one oldest and traditional method of determining the quality of precious metal like gold and silver. Cotecna use fire assay to accurate analysis various methods. Fire assay melting metal into a porous flat dish called a cupel and check the purity of metal. The last one is the ultimate quality standard. Multi-million-dollar mining contract depend on exact mineral percentage. Gravimetric unmatched physical accuracy make the definitive reference standard to use to calibrate and cross-validate automate electronic field sensor.
For the advantages of gravimetric analysis. First, we have the very high accuracy. Gravimetric analysis provide accurate measurement of the metal contents in the ore such as iron, copper, and nickel that's helping mining companies to determine the true value of their source. Second, we have the reliable for quality control. Mining and metal industry are use gravimetric analysis as a reference method to ensure the quality and purity of the extract metal for large ore samples. This method is effective for analyzing large quantity of the mineral and ore sample commonly found in the mining operation. Fourth, no calibration required. Results are obtained through the direct mass measurement, reducing dependence on the calibration standards and improve reliability. For the limitation of the gravimetric analysis in the mining and metal industry, first time consuming process. Mining laboratory may need longer analysis time because precipitation, filtration, drying, and weighing must be complete carefully. Second, we are not suitable for the low metal concentration. Ores containing very small amount of valuable metal may be difficult to analyze accurately using the gravimetric method. We have the labor intensive. This technique requires skilled analytic to perform multiple manual procedures, increasing workload in the industrial laboratory. Fourth, we have the less efficient for the high sample volume. Large mining companies often analyze many samples daily, making faster instrumental technique more practical in some laboratories. Gravimetric analysis play a significant role in the mining and metal industry. Throughout this presentation, we have seen how this method is used to determine metal contents in the ores, assess mineral quality, and support extraction and refining process. Its high accuracy and reliability make it valuable for quality control and industry decision making. Although the method can be time-consuming, it remains a trusted analytic technique in the mining laboratories. Therefore, gravimetric analysis continue to contribute to efficient resource management and the production of the high-quality metal product. Thank you.